Hello and Assalamualaikum. My name is Nur Shasha Rehana binti Shaiza. My matric number is AA211115. So today I will talk about the component that we will use in our project. So for the first component that we will use in this project is baseboard Node MCU. Baseboard is designed to ease the prototyping using Node MCU V3 board. It extends the GPIO of Node MCU to header pins, which also include the VIN, 5V, VUSB, 3.3V, and ground. So you can further use these pins for prototyping with the male to female jumper wires. So second is Node MCU. Node MCU is an open source firmware and development kit that helps to prototype or build IoT products. It includes firmware that runs on the ESP8266 Wi-Fi SoC from Expressive Systems and hardware which is based on the ESP12 module. So the next is ultrasonic sensor. An ultrasonic sensor is an instrument that measures the distance to an object using ultrasonic sound wave. An ultrasonic sensor uses a transducer to send and receive ultrasonic pulse that relay back information about an object's proximity. So for the last one is Servo SG90. Micro Servo Motor SG19 is a tiny and lightweight servo motor with high output power. Servo can rotate approximately 180 degrees and work just like the standard kinds but smaller.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Syaril bin Ahmad Tamizi and my matrix number is AA210652. And now I will explain about the functionality of the product by using the block diagram. So from the block diagram, we know that the ultrasonic sensor is connected to the VO pin on the Node MCU. Node MCU send the data to the blink to get the output that is the distance of the object. So ultrasonic sensor is the input. Next, the servo motor is connected to the V1 pin on the Node MCU. The Node MCU send a signal to this pin to control the position of the servo motor that has been set by the blink website. So for the input of the servo motor is the position that has been controlled by the blink website, and the output is a movement of the servo motor. And next, for the Node MCU, is connected to the Wi-Fi network and communicate with the blink library using the blink library. And from the blink library, it will send the sensor data from the ultrasonic sensor into the blink display. And by using the blink website, the user can use to control the servo motor and also see the data from the ultrasonic sensor in a real time. And the next is for the ultrasonic sensor is our input, which will be connected to the microcontroller that is a Node MCU. The other output of the project is a servo motor that will rotate when controlled by the user. Finally, the information from the ultrasonic sensor will be sent directly to the blink and show the distance of the object, which is the output in the blink website. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Amir Imran bin Abdul Talib and my number matric is AA2101X6. And as you can see in this figure, this is our prototype for the project. And for the project that have been used is the ultrasonic sensor, the Node MCU ESP8266, and also the servo motor. Okay, for the Blink website, this is our templates. As you can see, it will show that the device connected and the servo console. Then for the info, we use the ESP8266 for the hardware, and this is the coding which we used for the Arduino IDE. So what we need to do is we need to copy the coding and insert it to the Arduino. And as you can see, this is the ID and the device name and also the token for the Blink. And next for the metadata, as you can see, it's shown that the device name is servo console. So where we got the servo console, when we use the Arduino IDE, we can see that in the coding it was declared the servo console for the device name. And when we declare the servo console, the Arduino IDE will send to the MCU, and the MCU will send transfer the data coding to the Blink. So when we declare the coding in the Arduino, it will show that the servo console device name have been in the Blink website. And for the hotspots name, we doesn't need to put the hotspots to activate the prototype, because we already declare the coding in the Arduino IDE data. As you can see, it show that our the username and also the password for the hotspot. And for the data streams, you can see that the servo motor is for the output, and we use the V1 pin at the MCU, and also the maximum for the degree is 0 to 180. And the second one is the sensor. It is for the input. The pin that we have been used is the V0, and the minimum is 0 to 400 distance, 400 centimeter. And for the events, as you can see, it is show that they're online and offline. So where we want to know that the device is online, when the color turn to the green, it means that the device is already online. And the device, if it is offline, it will show that the red color. And this is our web dashboard. As you can see, the figure show that there is a slide, which means if you want to use for the servo motor as the input for the Blink, you can use the slider to set the degree for the motor to rotate. And as for the sensor, as you can see, it has a gauge, which means that it is for the distance for the user to know that how many distance that it can achieve. So that's all for me for the Blink website and the web dashboard. And for demonstration, I will pass it to Muhammad Ajwad Nabil to demonstrate the prototype of the project. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ajwad Nabil bin Muhammad Zaki. So my part is to demonstrate the prototype that we have made. So as you can see here, my device name, our device name is servo console, and status is online, which means we have connected to the Wi-Fi that I've been using. So for this dashboard, we have servo for our slide. Servo, we use slide for the servo, and we use gauge for the sensor. So to use servo, we have to turn to 180 degrees to move it. Why do we use 180? Because it is matched for the servo to turn. So if the servo turn in real life, it will turn like 90 degrees only. So that's it for the servo. For the sensor, we will use like this. We use ruler and breadboard to test the sensor. As you can see here, we have 10 cm, 9 cm for the sensor. Okay, so that's how the sensor works. That's it for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hikam bin Abdul Aziz, and my metric number is AA210 273. Now I will present to you about advantage and importance of IoT application. IoT application we will use is Blink, and its advantage or important is number one, improve safety and security. For example, IoT device can be used to monitor and control access to buildings and to detect and prevent security breach. Number two, remote monitoring and control. For example, IoT device can be accessed and controlled remotely through a smartphone or computer, which means you can monitor and control your device from anywhere. Number three, automation. For example, IoT device can be programmed to perform specific action based on certain conditions, which means they can be used automate repetitive tasks such as turning light on and off at specific time. Number four, improve decision making. For example, IoT device can generate vast amount of data, which means can be used to make more informed decision. Number five, increased efficiency. For example, IoT device can collect and transmit data, which means they can be used to optimize process and improve overall efficiency. Thank you. That's all for me.